What is differentiability and derivative? So what is the actual concept behind it? Before we go ahead, let me give you an example. Now you see here the fastest man on this earth. He made a world record of 100 meter 9.58 second. Now we know that 100 meter is the distance and the time is 9.58 seconds. So the distance is known, time is known, speed can be computed. Speed, we know speed is equal to distance upon time. Distance we know, time we know. But do you think this is a speed at a particular point? No. This is an average speed. The distance if you put here, time if you put here, it will be the average speed of Usain Bolt. But we are interested, or you are being told that try to find out the time at say 91th meter or say 11th meter. What was the actual speed? So that is called the instantaneous speed. And in order to find out the instantaneous speed, if we assume that the whole run was a function, that at particular point, if you are interested in finding out the speed, then we can draw a tangent at that point of that curve being found by the running. And that particular tangent, the slope of that tangent, that is tan theta, the slope, or you can say tan theta or m, that is the delta y by delta x. Delta y by delta x simply d2 by minus d1, that is the distance difference, and t2 minus t1 is delta x, which is time difference. But we want this d2 minus d1 to be as small as possible. So we write it as dy by dx. It is very small, very, very small, minute. So that is called the differentiability, and that is nothing but the slope. Slope is m is tan theta is perpendicular by base. So theta, just take tan of theta and that is going to be your slope, and slope is the instantaneous value of that particular curve at that particular point. Okay, so differentiability or derivative is nothing but the slope. Differentiability, because we need to find out for certain function. So precursor tells you that you need to know about the limits, you need to know about the continuity, then only you will be able to understand the differentiability. So there is a curve or there is a function and somebody tells you to find out the differentiability at x0, that is at certain point, instantaneous value of that unit or that function. So in order to tell whether this is possible or not, whether this function is differentiable or not, we'll go a certain step backwards, a certain step forward. That is the left hand limit and the right hand limit. F minus, that means we are going to add x0, subtract x0 minus h and x0 plus h. That is at x0, in order to find out the differentiability at x0, we just move a very infinite, least small, that is called h, which is h tends to 0. And we need to find out whether these limit exist or not. Left hand limit and right hand limit, they need to exist and they should be equal. The second very important thing for differentiability is the tangent at the left hand limit or left hand point and the right hand point. The tangent, if you draw, it should be the same tangent. That is the left hand tangent on the left hand limit and the right hand tangent on the right hand limit. They ought to be the same line. If you see, there will be various cases where these lines will not be same. So there are two things. Let me again tell you. First of all, the limits has to be equal, left hand and right hand, and the slope of the line drawn just at that point, both slopes should be equal. Now differentiability, there are certain cases where you can say whether it is differentiable, not differentiable. Now this figure shows that this is differentiable because as we just saw that the tangent at point ahead and just behind, the line should be same. The slope, the dy by dx, the m, the tan theta, all these are same thing, and these are nothing but the derivative or differentiability of a function. But the problem here is there is a straight line, that is the PAPB, the slope is equal, but it is a vertical line. But I am talking about tan theta. What is the tan theta? It is infinite. It is not defined. So when we have a vertical line, a tangent, because the vertical line has infinite slope, this function is not differentiable. Why this function, the right one, is not differentiable at x equals x0? Because if we just go a step behind or back, the tangent will be PA. The tangent just a step afterwards, the PB will be different. So the slopes are not equal. And the basic understanding or the idea is the slopes have to be equal, and they ought to have be falling on the same line along with the limit. The limit should exist and it should be equal. Derivative of a function, the concept is very simple. Then we'll talk about the derivative of various functions. But the concept of derivative is simply delta y by delta x, dy by dx. Speed is distance by time. What is distance? What is distance? Say y2 minus y1. What is time? Say x2 minus x1. So y2 minus y1 by x2 minus x1 is your average speed, right? So if you just make this delta is very small, very small, you call it as del or d sign, that becomes the differentiability or derivative of that function. You are going to make a tangent at that point where the differentiability have to be found out, and that tangent slope or the angle it makes with the x-axis, the tan angle, is going to give you the derivative. Now let me start from the basic. Say we have some x point, we just go ahead and we call it as x plus delta x, and we are talking about a function. So just there is a difference of the x1 and x2 have a difference of delta x. The delta x is very small. At x, say the function has value y1, and at x plus delta x, the value of the function is say y2. But we know that how to represent a function. We always represent a function by y equals fx. When we have y equals fx, so put the value of x, find out the value of y. And since we know the value of x, one is x plus delta x. So y1 we can always write as fx. y2 you can always write it as fx plus delta x. fx plus delta x. Now in order to find out the tan theta, what do we do? If this is a triangle, tan theta is perpendicular by base. This is perpendicular, this is by base. And how to find out this distance? That is the length of P and B. What is the distance? Let me just make a straight line parallel to x-axis and y-axis. So perpendicular will be y2 minus y1. That is tan theta is perpendicular by base. Perpendicular distance is what? y2 minus y1. What is the x distance? x2 minus x1. y2 minus y1 is what? fx plus delta x, because y2 is fx plus delta x. What is y1? fx divided by, this is x2 minus x1. x2 is x plus delta x, and subtraction by x, because x1 is x only. So this x gets cancelled, you get delta x. So this is the derivative of the function. But still we are not reached the derivative, because this delta x is not accepted. We need very small, very small, infinitely small. So small that it is actually equal to 0. So we'll apply the limit here. The limit delta x is so small that it can be regarded as 0. So this result is the derivative of a function. So we call it as f dash x, and we also call it as dy by dx. We also call it as y dash, f dash x, dy by dx. They are all the representation of derivative of a function. We'll try to find out the derivative of certain function here, but need to understand derivative is nothing but the tan theta m or slope or dy by dx or delta y by delta x is nothing but an angle. Let us take an example. If fx equals x square, and I'm not going to give you the direct result, I'm trying to suggest you how actually f dash x will be computed by first principle. So it will be fx plus delta x minus fx divided by delta x, and this delta x limit delta x or x tends to 0. Okay, what is fx plus delta x? Just put x plus delta x in this place. X plus delta is whole square minus fx is already x square, it is given in the question, and we have a delta x in the denominator. So just open it. A plus b whole square, a square plus b square plus 2ab, 2 into x into delta x, and minus x square, delta x in the denominator. X square gets cancelled. You get delta square plus 2x delta x. Take a delta x common from here. You get delta x plus 2x. Delta x in the denominator. Just cancel it out. You get delta x plus 2x. Limit delta x tends to 0. So just apply limit. Delta x will be 0. Only 2x will remain. So now you see what is the d by dx of x square. What is the f dash x of x square? It's 2x. There is one more very important theorem, or you can say result, which will be used immensely when you are doing the differentiation. It is y equals fx, and this is equals x to the power n. The differentiation of x to the power n is dy by dx is nothing but nx to the power n minus 1. The derivation is here. I'm not going into the detail. Just remember, it is nx to the power n minus 1. For example, you want to find out the differentiation of, say, x. So y is x is the function. dy by dx is what? X, you can write it as x to the power 1. So it is equivalent to x to the power n. N is 1 here. So 1 x to the power 1 minus 1. And x to the power n minus 1. N is 1 here. So you get x to the power 0. It is going to come as 1. So differentiation of simple x is 1. What is the differentiation of 1 to the power 1 by x? So you can write this as x to the power minus 1. You can take minus 1 in front. So nx to the power n minus 1. Minus 1 x to the power minus 1 minus 1. So minus 1 x to the power minus 2 here. So minus 1 x will come in the denominator, minus 1 by x square. So these are the standard result. One more, let us take one more of it. Y equals, this is under root x. Under root x is nothing but x to the power half, 1 by 2. So again x to the power n is half. So nx to the power n minus 1, half x to the power half minus 1. So it is going to be half x to the power minus half. So it is going to be half, and x you can take in the denominator, x to the power half, and as I tell you, x to the power half is root. So 1 by 2 root x. This is how the result will come. What about the differentiation of a constant value? When you take the differentiation of constant value, y equals fx is a constant value, which is k or c or some 2 or 5 or something. So you can write it as 2 into x to the power 0. X to the power 0 is 1 only. So x to the power 0 is 0, x to the power 0 minus 1. So you don't have to worry about x to the power 0 minus 1 because there is already a 0 multiplication. So this is going to be 0. What I am trying to suggest is that this differentiation of a constant value is going to be 0. Constant differentiation 0. Others nx to the power n minus 1. There are certain theorems, there are certain result, because there can be two different functions like x square plus log x. X square is a different function, log x is a different function. So when you differentiate it, you will differentiate x square and you will differentiate log x, and then you will just add. That is, dy by dx will be equal to du by dx plus dv by dx. U and v are different functions. Same thing will happen for the negative one. If you have a negative in between, same thing, log x minus x square, same thing. Now when you have a constant here, nothing will happen. You have to just take this constant in front. There will be no differentiation of constant. Constant will come in front. Whatever is remaining, just differentiate it as I told you about the constant value. Then we have a product rule, very important rule. When we have two functions multiplied, for example, x into x square, or say, because it will be x cubed, so I'll take another one, x into log x, or say e to the power x into x. So you will take one as u, one as v. So first you will take the first value, differentiation of the second value, multiply them, then addition of, when then you take a plus sign, then the first value and differentiation of the second value. That is, this is the f dash x plus gx plus fx plus g dash x. This is how you will do. So these are the product rule. Now, along with this product rule, because this will be used a lot. So when you have two functions or three functions, first you will start with two of them, apply this, and then complete the result. How about the division? When we have y equals fx by gx, then what you will do? There is a standard result here. You will take the denominator square in the denominator, that is gx square. Then you will take this denominator in first value. Then you will take the differentiation of the numerator. Then you will take the subtraction with what? The first value and this in the numerator and the differentiation of the denominator. So these are the standard result. Don't worry, don't need to mug it up. Just do the questions, you will understand it. There are certain standard results which I am going to tell you. The differentiation of sin x is cos x. The differentiation of cos x is minus sin x. The differentiation of tan x is sec square x. The differentiation of cot x is minus cosec square x. The differentiation of cosec x is minus cosec x cot x. Then we have e to the power x. There is no change. E to the power x is e to the power x only, differentiation. A to the power x is a to the power x log a. The base is now e. Then we have log x. The differentiation of log x is 1 upon x. And differentiation of log x, if the base is a, is 1 by x log a. Again the base becomes e. Right? So these are certain result which you need to know, because when you are doing differentiation, these all which I'm showing you will be used a lot. So they should be on your fingertips, need to be in your mind always, right? And the derivation is it has all come from the first principle. That is the basic definition of differentiability. So this is all about differentiability. Thank you so much. Take care of yourself.